Okay, so the people living in the people living in three houses are classified as children, parents, or grandparents. The numbers living in each house are shown in the table below. So we can see that in house number one, we have four children, one parent, and two grandchildren, and so on. Part 1 says all the people in all three houses meet for a party. One person at the party is chosen at random. Calculate the probability of choosing a grandparent. So, all of these people show up to a party, and one person is chosen at random. What would be the probability that this person is a grandparent? So, how many grandparents do we have? Two, three, four, five, six. So, numerator is favorable outcomes, which are six, divided by total number of outcomes. How many people do we have altogether? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So, 6 upon 16 should be the answer, which we simplify to 3 upon 8. Part 2. A house is chosen at random. Okay. That means either house 1 is chosen, or house 2 is chosen, or house 3 is chosen. Each of these would have a probability of 1 by 3 being chosen. So a house is chosen at random, then a person in that house is chosen at random. Using a tree diagram or otherwise, calculate the probability that the person chosen is a grandparent. Okay, so in house one, there you could choose a child, a parent, or a grandparent. So, probability of choosing a grandparent would be 2 upon how many people do we have in house number 1, 4, 5, 6, 7. So 2 over 7. In house 2, the probability of selecting a grandparent would be 3 upon, we have 3, 4, 5, 6, 7 people here. 3 upon 7. And in house 3, the probability of selecting a grandparent would be 1 over 2. So since we only need to look for grandparents, so you don't need to write the probability for child being selected or a parent being selected. So now we have to find the probability of selecting a grandparent. So we'll have to look at house 1 first, then a grandparent, house 2 and grandparent, and house 3 and grandparent. In fact, I should have written these probabilities here. Okay, so the probability of selecting a grandparent would be 1/3 times 2 by 7 for house 1 plus 1/3 times 3 by 7 for house 2 and plus 1/3 times 1 over 2 for house 3. This would get us 17 by 24. Sorry, 17 by 42. Okay. Part 3. Given that the person chosen by method in part 2 is a grandparent, calculate the probability that there is also a parent living in the house. Okay, so part 3 is conditional probability. It is on that a grandparent is selected, given that the person chosen by the method in part 2 is a grandparent. So given grandparent, calculate the probability that there is also a parent living in the house. So we have only two houses where a parent is living, house 1 and house 2. There's no parent living in house 3. That means in the numerator you'll have to look at house 1 and grandparent, or house 2 and grandparent. We cannot take house 3 in this case because there's no parent living in that house. Okay. Now we substitute the probabilities. House 1 and grandparent is this. So 1 over 3 times 2 over 7 plus house 2 and grandparent has probability of this 1 over 3 times 3 over 7 divided by probability of selecting a grandparent that we calculated in part 2. This goes in the denominator 17 over 42. Add all of this in the calculator and you would get 10 by 70. Okay, moving on. Question 5. Single cards chosen at random are given away with bars of chocolate. Each card shows a picture of one of 20 different football players. Richard needs just one picture to complete his collection. He buys 5 bars of chocolate and looks at all the pictures. Find the probability that Richard does not complete his collection. Okay, so Richard already has 19 cards. He is missing one card that he really wants to get. And in order to get that one card, he buys those 5 bars of chocolate and is hopeful कि उनमें से किसी एक में वो card निकल आएगा that he does not have. So he has bought 5 chocolates. 1, 2, 3, 4, 5. Okay, so uh, find the probability that Richard does not complete his collection. That means in all those 5 chocolates, he does not find that one card he is looking for. That means he could be getting any card of the other 19 cards that he already has. So it's going to be 19 over 20 the first time times 19 over 20 the second time times 19 over 20 the third time, 19 over 20 fourth time, and 19 over 20 the fifth time. Every time he is getting one of those 19 cards that he already has. So he's not getting to complete his collection. So in your calculator, you enter 19 by 20 power 5, which gives 0.77378 and rounded to
मैम
0.
प्लीज
Hmm?
समझ नहीं आ रहा
देखो उसने ना 5 चॉकलेट्स खरीदी हैं और उन हर चॉकलेट में वो कार्ड आ रहा है जो उसके पास पहले से है. सो एक वो कार्ड ही नहीं आ रहा जो उसके पास नहीं है. सो इन द फर्स्ट कार्ड द प्रोबेबिलिटी इज गोइंग टू बी 19 over 20. 19 कार्ड्स हैं जो उसको नहीं चाहिए आउट ऑफ 20, वो ही आ रहा है. सो 19 over 20 फर्स्ट चॉकलेट में आया, सेकेंड चॉकलेट में भी 19 over 20, उन्हीं 19 में से कोई एक आ गया. फिर अगले में भी यही हो रहा है, अगले में भी यही हो रहा है, अगले में यही हो रहा है. तो वो जो 1 over 20 हम लाने की कोशिश कर रहे हैं वो नहीं आया. So every time the probability is going to be 19 over 20 because he is getting a card that he already has. 19 cards उसके पास पहले, उसको एक और कार्ड चाहिए जो उसके पास नहीं आया in these 5 bars that he bought. So hence the probability is 19 over 20 power 5. ठीक है? Okay. Part 2 is he has the required piece exactly once. अच्छा अब एक दफ़ा इनमें से required piece आ गया. So required piece आने की probability होगी 1/20. So I'm writing that first. Let's say पहली दफ़ा में उसके पास 1/20 आ गए. That means पहली दफ़ा he got the card that he was looking for. So that probability would be 1/20. And then in the other four bars, he's getting the old cards that he already had. So that would be 19/20, another 19/20, another 19/20, and another 19/20. So he, in the first chocolate, he gets the card that he was looking for. I'm representing that with C. But in the other four, he got one of the old cards that he already had. Okay, this is how I'm showing it. So C means he got the required card and C slash means he did not get this required card. Okay, let me read the question again. He buys 5 bars of chocolate and he has the required picture exactly once. So ये भी तो case हो सकता है कि he does not get the card the first time but gets it the second time in the second bar and then does not get it in the other 3 bars. या ये भी हो सकता है कि he does not get it in the first chocolate bar, does not get it in the second chocolate bar, gets it in the third bar, then doesn't get it in the other two. And similarly, this C will keep traveling. Doesn't get it, doesn't get it, doesn't get it, gets it, doesn't get it, doesn't, doesn't get it, doesn't get it, doesn't get it, and then gets it. So you have 5 such cases. So in the second case, you'll write 19/20 times 1/20 times 19/20 times 19/20 times 19/20. Now, instead of doing this over and over and over again, we will just do it once and times it with 5. And this would be the answer. So, in your calculator, you'll enter 5 times 1/20 times 19/20 power 4, which gives 0.2036.
मैम 5 को मल्टीप्लाई करना है.
क्योंकि ये वाला केस है कि फर्स्ट चॉकलेट में से वो वाला कार्ड निकल आया, बाकी 4 में से नहीं निकला. फिर ये वाला केस है कि सेकंड चॉकलेट में वो कार्ड निकला. फिर ये केस है कि थर्ड चॉकलेट में वो कार्ड निकला, फोर्थ चॉकलेट में या फिफ्थ चॉकलेट में. दैट्स व्हाई यू मल्टीप्लाई इट विद 5. 5 केसेस हैं कि आपको 5 में से एक चॉकलेट में डिजायर्ड कार्ड मिलेगा. So that's why you write 0.5 and I've shown all the 5 cases here. Okay, so that's why you do a times 5. Okay, and the rounded answer is going to be 0.204. Okay. Part 3. He buys 5 bars of chocolate and looks at the picture. Find the probability that he completes his collection with the third picture he looks at. So it is this case. Okay, first में उसको अपनी required picture नहीं मिली, second में भी नहीं मिली, लेकिन third में मिल गई. ठीक है, so not getting the required picture is going to be 19/20 times, then again not getting the required picture would be 19/20, and then getting the required picture would be 1/20. Now there are other 2 cases as well because he is choosing 5 chocolates, but the other 2 cases become irrelevant because he got what he was looking for. Let's read the question again. He buys 5 bars of chocolates and looks at all the pictures. Find the probability that he completes his collection with the third picture he looks at. So third picture के बाद फोर्थ पिक्चर और फिफ्थ पिक्चर की प्रोबेबिलिटी पे फर्क ही नहीं पड़ेगा क्योंकि अब उसके पास सारे कार्ड्स आ गए. सो In the next one, the probability is going to be 20 out of 20 क्योंकि उन्हीं 20 में से कोई एक आ जाना है और फिर दोबारा से उन्हीं 20 में से कोई एक आ जाना है. So even if you don't write this, it doesn't make any difference. So the answer is going to be 0.045125, that we round to 0.0451. Question 6. In a certain country, 54% of the population is male. Okay, I'm going to make a tree diagram here. Although it doesn't say so, but it looks like a tree diagram question. Let's just start by making, yeah, it says so, by drawing a tree diagram or otherwise. Okay, so in a certain country, 54% population is male. So we can write male here and the probability would be 0.54, which means the female population will be 46, 0.46. It is known that 5% of the males are colorblind. So we can write colorblind here, and 0.05 is the probability that a male would be colorblind. That means probability that the male is not colorblind would be 95%, so 0.95. 2% of the females are colorblind. So we write colorblind here and 2% here, so 0.02. That means 98% are not colorblind females. So we have our tree diagram ready. Find the probability that this person is a male. Acha, a person is chosen at random and found to be colorblind. Find the probability that this person is male. Okay, so this is the case of conditional probability. Okay. So a person is chosen at random and found to be colorblind. So given colorblind wala case. So probability male given colorblind. A person is chosen at random and found to be colorblind. So given colorblind, find the probability that this person is male. Now we know the formula for conditional probability. It is probability male and colorblind divided by probability of being colorblind. Male and colorblind is this branch. So it's going to be 0.54 times 0.05 divided by colorblind. We have two branches for colorblind, the green one and also this one. So it could be male and colorblind or female and colorblind. So we do 0.54 into 0.05, a plus sign in between. Whenever you're hopping from branch to branch, there's a plus sign in between. And 0.46 into 0.98. So this would give, okay, this would be 0.7458 rounded to 0.746. You can even give your answer in fraction. So I'm also getting 135 over 181, which is also a good enough answer. Question 7. When Don plays tennis, 65% of his first serves go into the correct area of the court. I think this is also a question on tree diagram. Draw a tree diagram. Yes, let's start making a tree diagram. So when Don plays tennis, 65% of his first serves go into the correct area. So this would be correct area, and probability is 0.65, which means incorrect area. So the ball falling into an incorrect area would have a probability of 0.35. When Don plays tennis, 65% of his first serves go into the correct area of the court. If the first serve goes into the correct area, his chance of winning the point is 90%. Okay, so from the correct area, chances of winning a point is 0.9, and that means chances of losing a point would be 0.1, 10%. If the first serve does not go into the correct area, Don is allowed a second serve, and of these 80% go into the correct area. So if the first time it does not go into the correct area, he is allowed another serve, and probability that it goes into the correct area now would be 80%, so 0.8. That means probability that it does not go into the correct area would be 0.2, which is 20%. If the second serve goes into the correct area, his chances of winning the point is 60%. So from here, chances of winning is 60%, 0.6. So chances of losing would be 40%, 0.4. If neither serves goes into the correct area, Don loses a point. So if goes into the incorrect area, again the incorrect area, then he loses for sure. So probability of losing would be 1, and obviously then probability of winning would be 0. This is our tree diagram. We can write win, loss for more clarity. Okay. Use the draw tree diagram to represent this information. Done. Use your tree diagram to find the probability that Dawn loses a point. Okay, so we're going to follow all the branches where Dan is losing a point. So it goes into the correct area and then loses, or goes into the incorrect area, then correct area, and then loses. And then the third one is it goes into the incorrect area, again incorrect area, and then loses. So we will be multiplying the probability of these three branches and then adding them together. So first case is 0.65 times 0.1, correct area and loses, plus second one is 0.35 times 0.8 times 0.4, which is incorrect area, then correct area, but then loses. And then it's going to be incorrect area, again incorrect area, and then loses 1. All of these multiplied and added would give us 0.247. This is the probability that Dawn loses the point. Part 3. Find the conditional probability that the Dawn's first serve went into the correct area given that he loses the point. So probability given that he loses but it goes into the correct area. So probability correct area given loses a point. So from the formula of conditional probability, we'll write probability of correct area and loses divided by probability of loses. Okay, so Correct area and loses is this branch. So 0.65 into 0.1 upon probability of losing. Probability of losing was already found in part 2. That is 0.247. So we multiply and divide these and we get 0.263. Okay. Next is question 8. Okay. 8 is when Andrea needs a taxi, she rings one of the three taxis companies A, B, or C. Okay, I'm going to start making a tree diagram A or B or C. 50% of her calls are to taxi company A, so 0.5 is the probability. 30% to B, so we write 0.3 here, and 20% to C, 0.2. A taxi from company A arrives late 4% of the time. So late arrival is 0.04. That means on time arrival would be 0.96. A taxi from company B arrives late 6% of the time. So late and on time would be 0.06 and 0.94. And for company C, late arrival is 17% of the time. So 0.17 and timely arrivals would be then 83%, so 0.83. Okay, this is the tree diagram. Given, find the probability that when Andrea rings for a taxi, it arrives late. So if it arrives late, she might have called A and it arrived late, or B and it arrived late, or C and it arrived late. So we're going to find all these products and then add them. So 0.5 times 0.04 plus 0.3 times 0.06 plus 0.2 times 0.17. That would be 0.072. Given that Andrea's taxi arrives late, so probability given late, find the conditional probability that she rang company B. So B given late is the question. The formula is going to be B and L in the numerator divided by probability of being late, which was already found in part 1. Okay. So calling company B and getting the taxi late has a probability of 0.3 into 0.06 divided by probability of taxi being late is 0.072, which gives 0.25. Okay, question 8 is done. Data about employment for males and females in small rural area are shown in the table. A person from the area is chosen at random. Let M be the event that the person is male and E be the event that the person is employed. Part 1. Find the probability of selecting a male. So we'll find the total number of males divided by total number of people, and that would be the probability. So total male are 206 plus 412, 206 plus 412 divided by the total number of people, that would be the sum of all of these. So desired outcomes over total number of outcomes. This would be 206 divided by 427. Find the probability M and E. That means the person is also a male and also employed. So they're talking about this group, male and employed. So 4 upon 412 divided by, we've already calculated the total here. No, I did not write the total, so I'll have to add these together again. 206 plus 412 plus 358 plus 305. So it's going to be 412 male, employed males out of 1281. Sorry, 1280. Part 3. Are M and E independent events? Okay. What are independent events? If M and E are independent, then M and E should be equals to probability of M times probability of E. If M and E are independent. So we're going to check if this is true or not. So we've already found probability of M and E, which came out to be 412 upon 1281, equated to probability of M. Probability of M we also found in part 1. So 206 over 427 times probability of employed people. So these many people are employed, 412 plus 305 divided by total was 1281. For acha, I think I made a mistake. Probability of male would be 206 plus 412. So plus 412. Okay, so that gives 618 upon, okay, why did I miss this? Acha, ठीक है, I wrote the simplified answer. Never mind, this was correct. This was correct. We did find probability of male. Sorry, I got confused. So disregard what I just said. Okay, now we find this fraction and see if left hand side is equals to the right hand side. There was a 4 here. Okay, so 412 upon 1281 is equals to 0.32 something. And is it equals to the product on the right hand side? Let's see. So times 412 plus 305 divided by 1281. Oops. 206 over 427 times 412 plus 305 divided by 1281. I'm getting 0.2 something, 0.27002. So since they're not equal, hence not independent. Part 4. Given that the person chosen is unemployed, find the probability that the person is female. Okay. So, probability female given unemployed. So, we'll have to find the probability that the person is female and unemployed, and in the denominator, we'll find the probability that the person is unemployed. Let's look at the table. How many females are unemployed? It's 358. So 358 divided by total number of people was 1281. So total male and female combined is 1281. So probability of choosing a female that's unemployed is going to be 358 upon 1281. That's going to be the numerator. The denominator is probability of selecting unemployed person. So how many unemployed people do we have? Let's sum these. It's going to be 206 plus 358, that's 564. So probability of choosing an unemployed person would be 564 divided by the total number of people 1281. So this simplifies to enter it in the calculator and you'll get 179 over 282. Okay. My target for today was question till question 10, including homework. So inshallah we'll just get to finish question 10 and that means there would be no homework. So let's quickly do 10 as well and be done with it. Okay. Boxes of sweet contains toffee and chocolate. Box A contains 6 toffees and 4 chocolates. Box B contains 5 toffees and 3 chocolates, and box C contains 3 toffees and 7 chocolates. One of the boxes is chosen at random and 2 sweets are taken out. So if one of the boxes is chosen at random, the probability of selecting each box is 1/3. So box A will have a probability of 1/3, box B, and box C. All of these will have a probability of 1/3 of being chosen randomly. Okay, so one of the boxes is chosen at random and 2 sweets are taken out, one after the other, and eaten. Eaten means it's without replacement. So if you take out a toffee from the bag, the number of toffees decrease in the bag. Find the probability that they are both toffees. Okay, so from box A, probability of getting a toffee would be 6 upon, there are total 10 candies in it, so 6 upon 10. And then probability of getting a toffee again would be one toffee has been eaten, so the remaining will have 5 toffees out of 9 candies. So probability of box A being selected and then a toffee being selected and then again a toffee being selected would be 1/3 times 6 by 10 times 5 by 9. Plus we're going to do the same for box B. So box B has a probability of 1/3 of being selected, and then there are 5 toffees in it into 5 over total 5, 6, 7, 8 candies, 5 and 8. So 5 over 8, sorry, 5 and 3 make 8. So 5 over 8 is the probability of selecting the first toffee. It's eaten. Now there are 4 out of 7 toffees left. So into 4 over 7. Okay. We'll do the same for C and toffee and toffee. So box C has a probability of 1/3 of being selected. It has 3 toffees out of 3 plus 7, 10 candies. So 3 over 10. Now if this one is if this one is eaten, we have 2 out of 9 toffees left. So into 2 over 9. Multiply and add like shown here in the calculator, and you'll get 53 over 210 as your answer for part 1. Part 2, given that they are both toffees. Okay, so we know the probability that they're both toffees. So toffee and toffee, which was by the way already calculated here. This is the probability that both are toffees in or any of the 3 boxes. Okay, given that they are both toffees, find the probability that they both came from box A. Okay, so this is the conditional probability we have to find. So in the numerator, we'll find the probability that it came from A and both are toffees. And in the denominator, we'll put the answer of part 1, where both are toffees, no matter what boxes they're coming from. Okay, so the denominator will just be the answer of the previous part, 53 over 210. Numerator would be box A, toffee and toffee, which is this product. So 1/3 into 6 by 10 into 5 by 9. Enter this. So we'll get 70 over 159. Okay. Okay. All right. That would be all for today. And since we've met our target, there is no homework for the weekend. Take care. See you on Monday in class, inshallah. Allah Hafiz.